Hello everyone, my name is Saurabh Pant and really very sorry for being away from the YouTube for quite some time. Many works, as you might be knowing, that the offline coaching started and all of a sudden too much work also came. Plus somewhere I became a little lenient because the syllabus NEET was not releasing and I thought let's wait for the syllabus, then I will start. But now I think it's the end of Feb and it's already too late to start to wait for the syllabus now. And I think we should carry on with the preparation. Meanwhile, the NEET will release the syllabus, any changes will be there. We can delete the knowledge if we want. Addition, if I do later than this, might be very tough for you to learn and do the addition in your knowledge. So organic chemistry, many people were asking for the organic chemistry part. And I think the organic chemistry, many reactions I have already made in the playlist in very nutshell. But one reaction is there which is very, very important. And I have not given directly in the previous videos in the playlist of organic chemistry. That reaction is nucleophilic addition to carbonyl compounds. देखिए भाई, what is carbonyl compounds? Carbonyl compound is C double bond O. It can be aldehyde also, ketone also. R can be here, R can be here, ketone. R can be here, H can be here, aldehyde. So I'm just keeping it open-ended. The main thing is, whenever you have carbonyl compound, its carbon will have a delta plus and oxygen will have a delta minus. Because oxygen is more electronegative, oxygen has more tendency to attract the shared pair of electron. So little bit delta minus, delta means little bit negative he will get. As a result, carbon will get a little plus, delta plus. Now understand the organic chemistry majorly depends upon electrostats. People get a lot of confusions when they are reading organic chemistry because they don't realize that almost all the reactions in senior inter topics, the 4 chapters of organic chemistry in senior inter, they are based upon plus minus attraction. So electrostats everyone know, yaar, unlike charges they attract each other. That funda you have to use anywhere, wherever you will see the reactions. Electrophile, nucleophile will come. Make sure minus will attract plus and plus will attract minus. देखिए भाई. So in your reaction mixture you have a nucleophile. A nucleophile is a negatively charged species or maybe a neutral species having lone pair. In short, a person who will run behind a positive, a person who loves positive, who will attack on positive, that person is called a nucleophile. So in the solution, you have a nucleophile majorly. Electrophile present, very good, well and good. If not present, don't worry, H plus can be taken from solvent, that is water. Water will be giving you H plus as per the requirement. So what happens here is this. Carbon being delta plus, he is looking for someone with a delta minus or complete minus. So here the nucleophile comes into play. Nucleophile bhai sahab, he attacks upon this carbon because electrostats here minus plus attraction. So when the attack will happen, this carbon, if you see here, already have 1, 2, 3, 4 bonds. 4 bonds are there, 5th one is getting formed. So carbon, just like any other person, would like to complete octet only, will like to be stable only. But if a 5th bond is coming, his octet is going to get violated. He cannot make more than 4 bonds. So 5th bond is coming, what he will do? He will break his break his weakest bond. The weakest of all out of here is this pi bond. Because double bond is there, na? So 1 sigma, 1 pi. So this pi bond will be broken down here. So this pi bond will be shifted up. Why? To accommodate this 5th bond, it has to make a previous one so that the total bond remain to be 4 only. So what will happen here, yaar? Carbon, nucleophile, another bond here, and this O and minus. So this reaction, this first step of the reaction is going to be very, very slow. It's going to be a slow reaction, slow step. Why slow, sir? Arey bhaiya, why it will be fast? C double bond O is a stable compound. There is no logic that C double bond O would like to desperately come into the reaction. He's stable, he's a neutral molecule. He's stable. There is no big problem with C double bond O. But nucleophile was interested, so he attacked upon the C. No problem. But now problem came here. Kya? This was a neutral molecule. He was okay. Delta minus, delta plus was there. But yaar, in whose house problem is not there? In everyone's house, little bit problems are there. So in his house also delta minus, delta plus was there. But the house was not highly unstable. But as soon as someone came from outside and made a bond, a complete negative came on the oxygen. Oxygen is now very angry here. Ki carbon bro, you were living with me with a double bond, and as soon as a nucleophile came, you broke the bond with me. So this oxygen has a lot of negativity with him. This minus charge, this negative charge is desperately looking for someone to react with. If he finds some electrophile, If we find some person with a positive charge, that positive and this negative will attract each other at a very, very fast rate. So this step is going to be very fast, whether you have an electrophile or not. Sir, if electrophile not there, then this bhai sahab is now desperate for the reaction here. He was not desperate, he was a neutral molecule, but now he is desperate. He has got a negative charge now. He want to satisfy the negative as soon as possible. So you give him electrophile, he will react. You don't give him electrophile, he will take it from water. So bhaiya, electrophile given, let us say, or maybe it is taken out from water. Water have delta plus, delta minus, HOH is there. I am showing plus and minus for simplicity. Otherwise delta plus, delta minus is there. So this negative will take this H plus away and you are going to get COH, nucleophile, and this another group. It could be RH, anything. So here the sp2 hybridized C double bond O is going to become a sp3 intermediate and finally an sp3 product also. Carbon is going to be sp3 in the product. Here this is, if they ask you what is the intermediate, so people understand answers are very important in NEET exam. It's not about just the concept in NEET exam. Sometimes you will know the concept, but the word which they are asking, that you will not understand which language they have used. So dekhiye yaar, this intermediate is called sp3 hybridized alkoxide. Many people do not use this word alkoxide. So make sure that you start using this commonly used word in organic chemistry. Otherwise, what will happen? They will ask you a lallu question, in which of the following mechanism alkoxide is the intermediate, and here you will keep on scratching your head from where it came. And this is given in NCERT. So you don't have, we are not deviating from NCERT, but whatever is in NCERT, that cannot be taken a back seat, that you need to remember. So the intermediate of this reaction is going to be an alkoxide, alkane oxide. So alkoxide kind of an intermediate you are going to get. बहुत बढ़िया. So this is the reaction. Step number 1 is going to be slow. Step number 2 is going to be fast. Sir, first step is slow. Why? Because carbonyl compound was a neutral molecule. He was not very interested in reaction. But when the nucleophile attacked, he got a complete negative charge. And now the complete negative charge wants complete satisfaction. Bhaiya. So this negative charge will attack, will search for some electrophile. You give them electrophile, great. You don't give him electrophile, he will take from the solvent. Chaliye bhaiya. Now, this is the basic mechanism. We are going to read the reactions now. But before that, let's see the reactivity. On this one, salt example is there in NCERT. Make sure that you see that one also. Here I've written that as well. So generally, the reactivity of aldehyde is more than ketone. So if they ask you, this equilibrium is more on the right side for aldehyde or ketone. So sir, this equilibrium will be more on the right side for aldehyde rather than ketone. That means the reaction will go more and more forward in the case of aldehyde as compared to ketone. That means aldehyde is more reactive than ketone. Now this can be explained using again charges, electrostats, or I will take one simpler method to explain you. That if you have aldehyde, that means HC double bond OR, and you have a ketone RC double bond OR, and if I am the nucleophile and I need to attack upon that, so here I have a big R group who is hindering me to attack, and here I have two big R groups who are hindering me to attack. So here I will get lesser hindrance because this hydrogen is lallu pallu yaar. He is the smallest atom available for us. He will not show steric hindrance, but this R will show. Because of that, for me, for the nucleophile, for me it is very tough to attack on the carbon. In this case, because there are two R groups, but in this case only one R group is there, only one steric hindrance factor is there. That's why here attack is easy. That is by steric hindrance. Another method is there, how NCERT explains this. NCERT says कि भैया R will have a electron donating capacity. Here also R will have a electron donating capacity. Here more electron donation because R has HH neither gives electron nor takes electron. In that way you can understand for organic chemistry, for simplicity we say. R here gives electron, R here gives electron. This is plus I effect. What happens? Carbon here is delta plus. Why nucleophile attacked on carbon is because nucleophile was searching for a delta plus or a complete plus. And carbon had plus, delta plus. That's why the nucleophile attacked. Now, when R group is there, this delta plus, this plus is getting some electron density, and this delta plus, this positive charge slightly decreases because of the electron density coming inside from R. Here 2R, 2 nalayak R are giving इलेक्ट्रॉन डेंसिटी टुवर्ड्स कार्बन, तो सर डेल्टा प्लस विल डिक्रीज इवन मोर. तो आउट ऑफ दीज टू हु हैज मोर डेल्टा प्लस is aldehyde, because only from one side satyanash is happening. Here from two side electron density is there, that's why the delta plus is lesser. The nucleophile will be able to get attracted here more. So that is the second reason given to us. And as per NCERT, second reason they are explaining formaldehyde versus benzaldehyde. So they are saying formaldehyde is more reactive than benzaldehyde. Again, I would like you to say if they are comparing in the exam, if you are comparing the reactivity in the exam for nucleophilic addition of carbonyl compound, if they ask which of the carbonyl compounds are more stable, aldehydes given, ketones given, I would suggest you go with the steric hindrance because that is easier to check. See, sir, HCHO means C double bond O HH. Sir, you only told us ki HH are lallu pallu people, they will not do any steric hindrance. Whereas this nalayak benzene is very big, sir. And when we write the structure, we understand one side to lallu pallu hydrogen is there, but the other side big benzene is there, sir. He will show more steric hindrance. So automatically reactivity will be lesser. This will more or less for NEET exam will give you the correct answer. For JEE to JEE advanced, so suddenly they can ask you anything beyond the syllabus as well. From the beyond the syllabus, so I should not say. Syllabus of JEE advanced is very vast. Beyond NCERT and related books also, they can ask you some skeptical type of examples where you need to be a little bit of what we should say data oriented rather than logic oriented. But in NEET examination and JEE main examination, they mostly favor the result on the basis of the prediction. Like prediction means the trends. And as per the trend, general order is there, aldehyde more than ketone, and larger ketone, less reactivity, smaller aldehyde, more reactivity. Basically the groups are small, hindrance is less, reactivity is automatically more. So this is the first part. Now I'm quickly going to remove this and continue with the lecture and write the reactions of this type where the nucleophile electrophile will mention one by one. Let us carry on. Chaliye bhai, now let us see the reaction of CH3 C double bond OH ethanol with HCN. ठीक है भाई. So what happens in the case of HCN? There is a little bit satyanash here. क्या? HCN भाई साहब ना. First I'll tell you the direct reaction so that those people who are just starting with the organic chemistry and they are very afraid of organic, they should understand there are always shortcuts of finding the answer if you have a little bit of common sense. देखो what I told कि भैया देखो delta plus here and delta minus here. In HCN it is acid, so some plus H will have, H plus will be there, you can write complete plus also for your simplicity, and CN minus. तो obvious है यार, minus attract plus and plus attract minus. तो directly you can attack like this कि भैया ये oxygen will take the hydrogen and this carbon will take the CN minus. So what kind of product you are going to get? You will get CH3, C double bond O will become C single bond OH. Why? If this CO bond is there, oxygen taking hydrogen, carbon taking CN, so double bond not required now, na? They were satisfying each other's valency. Then they decided, nahi yaar, we will break up here. O will take H and C will take another CN. So this CN will be taken here and this will be the product. This is called cyanohydrin. So in case you just want the product, this is how you can directly write. There is no need of going into the details of it. And most of the times the NEET exam or JEE mains also, they will ask you the question directly of the product and this is how the product will be written. This is called cyanohydrin. Don't forget that the intermediate of the mechanism is called alkoxide as well. So keep that also in mind. Names are important. Sometimes you will not understand what they are asking in the question, even though you will know the concept. Chaliye bhai, this is the reaction, elementary level, over, no problem. Little bit going into the detail. Dekho yaar, satyanash is this SCN is having a covalent bonding here. This is a covalent compound. That means there is not a complete negative charge, a complete minus charge, a full minus charge is not there. It's a covalent compound. You have a delta plus and a delta minus. So basically the reaction is very, very slow here. The real reaction of HCN with aldehyde or ketone, both of them, it's extremely slow. With ketone, even slower, but and even less product dominating. But right now also the reaction is slow. So to increase the reaction, what we do? This is base catalyzed. Base catalyzed means the base will increase the rate of reaction. देखो भाई, very interesting and very simple यार. HCN in the presence of base, what he will do? HCN in the presence of base, देखो भाई, HCN was not ready to react. HCN was like, yeah, bro, I don't want to react. Then they asked, why don't you want to react? Yaar, so nice scenario you are having. You can make a cyanohydrin together. HCN said, nahi yaar, I'm already stable. There is not a complete plus or minus charge with me. So OH minus came. OH minus motivated HCN. Kia bro, give your H plus to me na. I will form water. OH minus and H plus. So what will the CN form? CN will go out as CN minus, and this is a complete negative charge here. So understand, base catalyzed reaction, what happened in this case is OH minus took the H plus of HCN away. HCN is a weak acid. Do not forget, he is a weak acid. He will not dissociate 100%. But in the presence of OH minus, he will attract H plus. What he will form? Manchinelu. Water gone. What is left? CN minus left. Now CN minus is a very awesome nucleophile. In this scenario, he was a bad nucleophile. Sir, why bad nucleophile? Are neutral hai na wo? HCN is neutral. HCN is neutral. A neutral person will attack on a neutral person. Why? What is the logic? You are stable, someone else is stable. Why will you react with each other? Zero motivation, but a little bit motivation, delta minus, delta plus. But when HCN came in the basic medium, CN minus reaches. Now CN minus is very, very desperate for the reaction. He has a complete negative charge. Now what will happen? Now this RC double bond OH that you have taken with CN minus will come. CN minus attacks here very, very rapidly. Now again, step number 1 will be slow only, but faster than this. Slow step only as compared to 2 steps I will write. Out of the 2 steps, first one is going to be slower only because at least one is neutral. Na? So what will happen here? RC, CN minus attacks, the bond will open and shift up. The bond will shift up, O minus here, बहुत बढ़िया, CN here, H here. Then from the aqueous medium, he will extract the proton and you are going to get R, C, CN, H, OH. And this is your cyanohydrin. But the only difference is that HCN in the acidic medium will show a very, very slow reaction. In basic medium, very fast reaction. If they ask you why, answer will be very simple. Sir, HCN bhai sahab is neutral. Not much desperate for the reaction. But in basic medium, he becomes CN minus. CN minus means complete negative charge. Bhad bhar ki reaction will happen, sir. चमका भैया, चमक ही गया होगा. रिप्लाई तो क्या ही दे पाओगे तुम. देखिए भाई, CH3 C double bond O CH3 with NaHSO3. One ketone I have taken just for change. Now, in such kind of a reaction, what will happen? Again, you have Na plus and HSO3 minus. So, lallu thing I will do right now. I will not explain the mechanisms now one by one because mechanism to I think you have understood. Ki nucleophile will attack first. Slow step. After that, the electrophile will attack. If not available, then the proton abstraction will be done from solvent. Or solvent will give the H plus in simple words. Now, what the reaction is? Na plus will go and attach here. That means the lone pair will attack on Na plus and take it. And HCO3 minus attach here. So you are going to get, see how beautiful this will look like. C, CH3 and here HSO3 minus has come. So I'm writing it like OSO2H because negative charge is on oxygen. Negative charge will be on the oxygen. So O minus is there, O will attach there and SO2, that means basically it is SO3H only. And here you will have O minus Na plus. Now, to make it look a little better, what I am doing, because they all are at 109.5 degree almost from each other. So all the positions are equivalent only. So for simplicity, I am showing it here, O, SO2H and I am showing the methyl here. ठीक है भाई? Why? Because I have to tell you now कि whenever there is a proton available from a stronger acid and there is a O minus available from a weaker, we should say a base, छोड़ो weaker stronger, a base. तो भैया H plus can get transferred ना? Simple word है. If you have acid and base in the same compound, leave safe compound, you have one acid and one base, they will react with each other na? अब think in this way, acid and base, they both are in the same compound, so then also they can react and more rapidly they can react. Here, this H plus and this O minus are in the same compound. So a quick proton transfer will happen. H plus transfer. So basic acid base reaction hai. H plus will be going happily and jumping to this O minus, and Na plus will be exchanged here. So what you will get CH3COH. H got shifted here, bhai, and here CH3 as it is, and here OSO2Na. It's not looking very good. I will write it properly. देखो भाई, OH will come here, CH3 OSO2Na. So what happened was, don't get worried about it. It's just a simple acid base kind of reaction. कि यार देखो, proton was available, O minus was looking for someone, or O minus had Na plus ना, हाँ, but Na plus and O minus, they are forming ionic bond, not a covalent one. So O minus was there, Na plus was there, but in aqueous medium it is ionized. Ionized means what, sir? Dissociated. Just like NaOH is there. NaOH goes into water, will become Na plus and OH minus, na? In the same way, this ionic compound is also dissociated in the aqueous medium. So this O minus was existing like O minus only here. Na plus was only there for namesake. Na plus is hydrated, Na plus is separate, and this bhai sahab is separate. So what they did, they decided, yaar, this H plus, SO2 minus decided ki I don't need H plus as much as this O minus need. So he gave the H plus to him, and he himself took SO2 minus. Chamka bhaiya. If someone asks you, sir, why he does not need, he does not want to be stable? He wants to be stable, but in a family, sometimes if you are already having chances of stabilizing yourself by conjugation, and your brother is there, he needs the money more, you'll give him the money, na? That's what the family is for. So what you will do, this O minus, he needed this H plus more desperately. The SO2 minus group here was still having some conjugation, was still having some stability due to conjugation. So they sacrificed, ki chalo theek hai bro, take this H plus with you, no problem at all. Now this is a crystal. So sometimes we use this as a test also for aldehyde and ketone. What kind of test? If you have aldehyde ketone and you are suspecting that maybe aldehyde ketone is there in the container, add NaHSO3. If crystals comes down, some crystal means some solid substances precipitate down, that means this compound has been formed, that means aldehyde ketone was there. So NaHSO3, sodium bisulfite, sodium hydrogen sulfite is a test, is a reagent which is used to test the presence of aldehyde and ketone also. Very, very awesome reaction. One more interesting thing. In case you want this compound to become aldehyde ketone again, you don't have to do a hi-fi thing. All you have to do is add acid. Add HCl, no problem, add acid. What will happen? This thing will become the ketone again. ठीक है भैया? Sir, how it will become a ketone again? I can explain it. Everything we are going logically, so let's go here also logically. There is no hurry as such. Moreover, you can anyway forward and check. So that is the advantage. CH3COH CH3O SO2 minus Na plus. Let's say I add some acid. What will happen? If I add some acid, na, this bhai sahab Na plus, this bhai sahab will go. ठीक है? Secondly, this will also get protonated and become H2O plus. Then what will happen? Nothing, yeah, he will try to go away. So chalo badhiya, gone. Then what? Then this lone pair will also try to go away, and automatically you will be getting the ketone that you previously had. ठीक है भाई? Why he will go away? अरे Manchinilu is very stable, he will go away easily. That's not a problem. Then sir, why this lone pair comes here? अरे भैया, when Manchinilu will go, neutral water will go na. Positive will be left behind, and to satisfy this positive, the lone pair will shift. Clear hai bhaiya? So when the lone pair will shift, you will get the ketone back. So basically, sometimes to protect this ketone group also we do this. If some reagent is there, he's looking for ketone, where is ketone, I will kill ketone. And you are like, no, ketone, so we can't let it go. We want to use ketone in some other reaction. So what you do, you will convert ketone into this compound, this crystal. So what will happen? There is no C double bond O available. So I will come, ketone kahin. I will not be able to find ketone. You will be very happy. Reagent will go. Then again you add acid. You will get your ketone back. So wherever you want to use ketone, only there the ketone will be used. So it is sometimes used as a protection also against some reagent who are probably trying to react with ketone and aldehyde. Moreover, this is also used for purification. As per NCERT, the major use of this reaction is used for purification of aldehyde ketone. Sir, how, sir? Think about it. Some impurities are there and aldehyde is there. You want to separate aldehyde and you want to separate impurity. Add NaHSO3. NaHSO3 will not react with the impurity, will react with aldehyde or ketone, forming crystal. Pour the liquid out, take the crystal out. You got the crystal. Crystal contains this. Now take crystal in a new container, sprinkle some acid over it, you will get the ketone back. But this time pure ketone. Where are the impurities? Gone in the liquid. क्या बोला? Impurity was there, aldehyde ketone was there, I added NaHSO3, aldehyde ketone forms crystals. Precipitate down. Remove the liquid. That liquid contain impurity. Crystal contain your actual aldehyde ketone. Add some acid there, you will get the aldehyde ketone back. So NaHSO3 reaction, sodium bisulfite reaction is used for the purification. So now is the last part of the reaction. Let's wrap it up. So we are having, let's say, CH3CHO again, and we are passing it over dry HCl in the presence of C2H5OH here. Now this is a very important reaction. Why? Because here you have to understand C2H5OH is neutral. He is also neutral. So no one is actually desperate for the reaction. Same condition was with HCN also. So what we did to make the HCN react, we gave the basic medium so that the HCN becomes Cn minus, and Cn minus is completely negative charged. As a result, he became desperate for the reaction and the reaction happened quickly. Here, we have both of them neutral and we use dry HCl. Sir, what's the rule? Dekho. It is delta plus, delta minus. Here also, oxygen is there, delta minus is there. So this delta minus is going to attack on carbon. Delta minus, delta plus, attraction will be there. Plus minus will attract each other. Everything is okay. Problem is desperation for the reaction is not there. Yaar. So to motivate them for the reaction, dry HCl is taken. This H plus bhai sahab will bind with this oxygen. As soon as the oxygen bind with the H plus, this dry HCl, this bond will shift up. Why, sir? Arey bhai, oxygen was in a requirement of 2 bonds. Oxygen have 6 electrons in the last shell. 2 more bonds will be formed. Automatically octet will be completed. So oxygen was making 2 bonds with carbon. Then he found a better opportunity that your oxygen I can bind with the hydrogen also. I'm oxygen, I can bind with hydrogen also. Yaar. So he took the H plus and bhaiya automatically he became converted into OH, and this carbon as a result got a complete plus. Why? Because this bond got shifted here. And when the bond got shifted means this oxygen took both his electron and the carbon's electron also, and gave it to hydrogen. Why, sir? Because hydrogen don't have electron. Exactly. H plus do not have his own electron. Hydrogen contain 1 electron. H plus contain 0. So if anyone want to make a bond with H plus, they have to give electron from their side. So that's why this oxygen took the electron from carbon also and give it to H. Bhaiya, I don't need you carbon. Carbon is getting a complete positive charge because of the shifting of this bond. Now the attack becomes very fast and this O attacks on this carbon and you will get CH3. C, I can write H here now. This CH3 I am writing here and this H I am writing here. Now here what I am writing OH here. The H is taken by dry HCl from the dry HCl, and here you will get OC2H5. This thing is alkoxy alcohol. If you see it is alcohol, but this is alkoxy, ethoxy better to say. In more precise word, if I say this is ethoxy alcohol, ethoxy alcohol. Ethoxy alcohol is there. And this is called as hemiacetal. Clear bhaiya? This name of this compound is hemiacetal. Then this bhaisa will react with 1 more C2H5OH. Don't think in the presence of H plus I am saying. It just react with 1 more C2H5OH and kind of a substitution happens, and this OH bichara is going out now, and you will get OC2H5, OC2H5, here CH3 and here H. Clear bhai? This delta minus attract on this delta plus. So why delta plus? Because bonded to 2 oxygen atom. Oxygen is more electronegative, they will drag the electron away. As a result, delta plus here, and this delta minus oxygen will attack on this carbon with delta plus, and this OH will go. So what you will get OC2H5, OC2H5. Clear hai? If anyone get this doubt, it's basic common sense. Ki sir, if this will attack, why he is not going? If he will attack and he will go, same compound is there na? लगाओ थोड़ा दिमाग समझ में आएगा. चमका भाई. तो OC2H5, OC2H5, both of them are there. Both. Clear? In such case, we call it gem. Gem means whenever there are two groups on the same carbon, we call it gem. Gem. So gem dialkoxy. There is two alkoxy or two ethoxy, we can say. Gem diethoxy. Two ethoxy group on the same carbon. So gem diethoxy, which is also known as acetal, because it is made from aldehyde or acetaldehyde. That's why we are calling it acetal. It has a hydrogen atom there. So this is acetal. Think about it. If same reaction somehow we can do in that way that these two carbon are attached to each other, then what will happen? Then this kind of a compound you will get. This O and some bonding like this, a ring-like structure you will get. This is exactly what we do in the case of ketone plus ethylene diol. Understand one more thing. It's not compulsory that only with ketone this will be shown. With aldehyde also, but with ketone this is generally taught in the class because NCERT writes this reaction, and it's as in the exam also for ketone only. So you have CH3, C double bond O, CH3, and CH2OH, CH2OH. Like here we give C2H5OH 2 times, once, twice. Here we are giving 2 CH2OH together only. So what will happen? Directly final product CH3CH. Here CH3C, CH3 there, so CH3C, CH3. Right side OO. C2H5, C2H5, here also CH2, CH2, but it is bonded to each other already in the reactant here, still bonded here. This is ethylene glycol ketal, because methyl here, so ketone it is coming from. Origin is from the ketone, we are calling it ketal. Origin is from the acetaldehyde, we are calling it acetal. Chamka bhaiya. Now the beauty of this reaction is this is used for the protection of ketone group. Previous reaction used for the purification of aldehyde ketone, NaHSO3 reaction used for the purification, separation of aldehyde and ketone, and this reaction ethylene glycol with ketone is used for the protection of ketone group. How? You want to protect ketone group from some invader, someone who is ready to react with him. You should give ethylene glycol, ethylene diol we can say, ethylene glycol we can say. So what will happen? This OO will come here, and bhaiya ketone is not visible, but as soon as we add dilute HCl, immediately this will get converted to ketone again. Just like the previous method I have told, this will get converted to ketone again. So if you want ketone back, add little bit of water and HCl. It will go back to ketone. If you want the ketone to be protected and the person should not be able to identify ketone, for someone who is there, some nucleophile is there, you don't want ketone to react with that nucleophile. So what you will do, you will take this ketone or any ketone, you add ethylene glycol there, ketone group will be protected. So this is the protected ketone group. Protected ketone group. And whenever you need ketone back, add dilute HCl, ketone will come back to you. So this is the reaction of alcohol with aldehyde and ketone. Keep this in mind, practice this reaction 2-3 times, you'll be able to get it. Easy one. Last but not the least is the Grignard's reagent. So Grignard reagent is RMGX. Understand, metal is always having a plus charge and R will always be having, because of metal having positive charge, he will be having a negative charge. If they ask you the product of this reaction with aldehyde or ketone, same lallu thing yaar, same method. R, this is delta plus, this is delta minus, plus minus attracts, sir attack here, this minus will attack here, sir CH3, C, R, CH3, sir O minus MgX plus. So MgX, or don't write minus plus also, if you are not comfortable, hatao usko, no problem at all. Minus attract plus, plus attract minus, just stick them in the right place. If you are sticking in the right place, this thing, reactions will never give you wrong product. Then little bit of H plus from somewhere if you can get na bhai, this oxygen will give you a lot of blessings throughout your life. He will take the H plus and will give you CH3Cr CH3OH, and it became a tertiary alcohol. You will take aldehyde, like ketone was there, so tertiary alcohol. If I take aldehyde, what will happen? Lo bhaiya, H came. Here also H came. Here also H came. You got secondary alcohol because carbon which is having OH group connected to 2 carbon, that is called secondary alcohol. Okay, bhai. If I take acetaldehyde, formaldehyde, 2 side hydrogen atoms are there. So here also hydrogen will come here, both side hydrogen atom. So it will become a primary alcohol, RCH2OH. So any kind of such compound you can make by Grignard's reagent. There is no mugging at all. R has a delta minus, MgX has a delta plus because metal hai, so metal will have delta plus here. R will have automatically delta minus. Here carbon is less electronegative, so delta plus. Oxygen more electronegative, so delta minus. So attack will happen, just stick them in the right place. Plus will attract minus, minus attract plus. So the final conclusion is all the reactions. Quickly we can see what we have seen. We have seen that whenever there is a reactivity comparison of nucleophilic addition to carbonyl compounds, aldehydes more than ketones, and in formaldehyde versus in propanol versus benzaldehyde, they have given propanol is more reactive than benzaldehyde. I told you the trick, focus upon the steric hindrance, you will get the correct answer. Then for NEET and JEE main. Next, number 2, what we have seen? Number 2, we have seen the reactions. In reaction for first, number 1, HCN from cyanohydrin. Cyanohydrin reaction is there, but very slow reaction. So we take the basic medium. HCN, a neutral nucleophile, get converted to a negatively charged nucleophile, and very awesome quick reaction happens there. Cyanohydrin formation happens. NaHSO3 used for the separation and purification of the aldehyde ketone because it forms crystals, which can be later on converted back to aldehyde ketone by just adding a little bit of acid. Same to same you can do for ethylene glycol as well. When it reacts with ketone, it forms a cyclic compound like this, which is ethylene glycol ketone. And this thing also, when added with dilute HCl, will go back to aldehyde ketone. So it is a protective reaction for ketone group. How the reaction actually occurs is very simple. Again, C2H5OH, C2H5O will attack here, H will attack here. Dekho, this thing I can explain to you in very simple language also, just like forget the mechanism in case you want only product. Just focus upon C2H5OH. So sir, C2H5O delta minus, H delta plus. So sir, this will attack here, this will attach here. That is the product. So OH, CH3C, O, C2H5H. So exactly this product is formed. Then C2H5OH will attack, OH will go. Again, kind of substitution reaction is there. You might have read in the alkyl halide, or maybe if not, you can just check the SN1, SN2 mechanisms in the reaction of, I think, organic chemistry playlist is there. There you can see second or third video is there. Something mentioned in the description or maybe in the title of the video will be there, SN1, SN2, that you can check out if in case you want. Or just simply remember, yeah, someone will come, someone will go. This is called gem dialkoxy. I focus upon the names also properly in this video, so make sure that you read the NCERT now. 2 pages are there. A quick reading will give you sufficient marks in the NEET examination. Thank you so much. All the best. Let's meet in the next video now.